All right, here's a good question. You're asked to solve for x. You notice that all the bases can be changed to a base 3. So 27 is 3 cubed. Leave this one alone. And then 9x squared, the 9 would change to 3 squared, and then you'd have an x squared up there. Okay, let me just sort of simplify that part. So let me rewrite this. And then this is power of a power, so I multiply those two. So it'd be 2 times x squared would just be 2x squared. Okay, now I need to get it so that it's 3 to the something equals 3 to the something. But I've got 2 3's here, so I have to combine those. Oh, sorry, excuse me. So to combine them, use the product rule of exponents. If you're multiplying common bases, add the exponents. So this is going to be 3 to the 5x plus 2x squared. Okay, now bases are the same, so I can equate their exponents. So 3 is equal to 5x plus 2x squared. Let's rewrite it. I'll do it over here. Rewrite it so everything's on the right side. So 0 equals, I'll put 2x squared first, plus 5x. When I bring the 3 over, this will be a negative 3. Okay, now I factor. And you can use the group factor or the AC method or whatever you want. I think it'll be 2x here and an x. And then 3 and 1. So I think I'll put a plus 3 here and a minus 1 there. Let me just check. 2x squared plus 6x minus 1x gives me the 5x minus 3. Good. So then 2x minus 1 equals 0, or x plus 3 equals 0. So 2x, adding 1 to both sides, and then dividing both sides by 2. And on this one, just subtract 3 on both sides. So x equals a minus 3. So you'll have two answers there. Since this is an exponential equation and not a logarithmic one, I think both of those answers would work. But you could plug them into decimals and just see if one side's equal to the other.